So hi everyone, welcome to Mark and I's video presentation on our engineering project. So in this video for the next 5 to 10 minutes, Mark and I will be giving you a rundown of how our project came to be and how we brought it to life. So I hope you enjoy.
It's a rock, paper, scissors robot I just built.
What?
Its sensors anticipate your next move.
Maybe for civilians, but I've been training the art of sleight of hand. At last, a worthy opponent. And not just because you built a nearly unbeatable robot. Damn it!
Okay.
The paper towels, the paper plates on the toilet. Rock! Ow!
If there are any Modern Family fans watching right now, this scene may seem familiar to you. In this scene in the Modern Family, you can see Phil, the dad, go against and try to beat this robotic hand that is placed on the table, and sadly is unable to. This is what inspired Terry and I to create our own version of this unbeatable Stone vs. the Robot.
A quick little Google research and we were introduced to the Janken robot that was created by researchers at the University of Tokyo in June 2012. And they were creating this robot that was very similar to the Modern Family robot, so we used this robot as inspiration since it was basically a replica of what Modern Family had featured in their show, and it also had a winning rate of 100%. So we used that as our inspiration.
Now, of course, this robot took months and months to complete and probably used a lot of high-tech design. So how were we, two high school students with little to no engineering and coding experience, going to pull this off?
We knew that we were not going to be able to create a project that reached the same levels as the Janken hand, but we also knew that we had access to the starter kit, the Arduino starter kit, and this gave us almost everything we needed to build something that was really kind of similar to the Janken hand, but not as technical and as challenging.
There were multiple videos online that had created downsized replicas of the Janken robot and using the Arduino kit, which allowed Terry and I a head start in the project.
We chose this video as inspiration and then started working on our product design.
From the video, we chose to do a similar mechanical system by using motors and strings to move the hand, but apart from that, everything else was created by ourselves with the help of Mr. Zueme and Mr. Minzong.
So from the Arduino starter kit, we used their jumper wires, 2 LEDs, a push button, an ultrasonic sensor, and some resistors. However, this starter kit didn't provide us with everything that we needed for our project. So for the rest of the stuff that we needed, Mr. Min provided us with the Arduino Nano board and shield and 2 MG995 servo motors. And lastly, for our entire project, we used a computer so that we could code the Arduino codes and basically input all the directions into the circuit and make the hand move. So for the actual hand design, we wanted an actually built hand that we could show and use when we were going to create the project. So because of this, we opted for 3D printing. And we watched this video specifically and we recreated whatever he made, because what he did was he provided us with all the designs and the files and the instructions on how to recreate what he did. So that's what we did overall for the hand design.
However, 3D printing wasn't our first choice. We were first going to go for an already built wooden hand, like those ones they use for reference model and sketching. And we were going to attach strings onto each of the fingers and drill a hole through the forearm area so the strings could neatly be placed.
Using this concept, we created a prototype to fully show what we had in mind, and as you can see from the cut open square in the middle of the hand, this idea was not going to work.
We did this prototype after we were told the idea of the 3D printing instead, and we went along with the designs and functions that the 3D printing video already provided for us. How the motor pulley system worked was that we attached all the strings to one motor and 3 specific strings to the other motor.
This means that if motor A was pulled, then all the strings would then pull all the fingers and it would resemble a hand doing a rock shape. So basically motor A pulls all the fingers. And if motor B was pulled, then only these 3 strings would pull. String 1, string 2, and string 5, and it would resemble an overall scissor shape. However, for paper, we made none of the motors pull any of the strings, and that meant that the hand would just stay neutral. It wouldn't move, so that would also resemble the paper shape during the rounds when you play against the robot.
Now let's explain the electrical part of our project. After the hand was completed, we started working on the electrical aspect of the project and completed it with the help of Mrs. Wagner. After the electrical part was completed, we were basically done with the project. We just attached the motor to the strings and we're done.
So, in conclusion, I would say that the electrical aspect was probably one of the most challenging parts of the whole thing, since it was something that both Mark and I were foreign to. We had no idea what breadboards were or what even was a ground or a shield.
However, this doesn't mean the mechanical part is any easier.
Right. We stumbled onto a lot of issues on mechanical as well. For example, when we were glue gunning the fingers onto the palm of the hand, we basically glue gunned one of the holes on the fingers shut, so we couldn't put the strings through the fingers anymore. So we had the worst time trying to take the glue off of the finger. Attaching the strings to the motors was overall the most challenging part in mechanical, I would say, since the motors didn't have that strong of a pull.
Yeah, however though, and I think we both can agree that if we were to choose which was the hardest, I would say was electrical.
Yeah, I agree. And to conclude, I would say that we did a pretty good job bringing our stone, paper, scissors robot idea to life. However, if I were to state something we could have done better, it would be to have done more background research on almost everything and to have done more test runs.
Yeah, I agree. I think if we looked at more research on how much strength servo motors have, then we wouldn't have made the mistakes that we did. And if we had done more test runs, then we would have been able to identify mistakes that might have reoccurred when we created the real final outcome.
Yeah, I agree. I feel like if we had done all of the things that Mark and I have just mentioned, I think things could have gone a lot more smoothly.
Yeah, but however, I'm satisfied with the outcome.
Yeah, me too. I am very satisfied with the outcome as well. And I hope you guys enjoyed this video we made. And I hope you guys liked our robot as much as we do. So also here are just some clips that we're going to add of the robot going against some players and stuff like that. So thank you guys for watching and bye bye.